So I debated, I've got some videos with tornadoes and that sort of thing. The one I have is like 25 minutes. I've got a couple of them, 26, 30 minutes. But I couldn't decide if that's how I want to spend the time in this class. I for sure want to get through this chapter 10 on Midwest severe weather. This is just getting on my nerves. But I don't know if there's a good chance what I'll probably do then is just begin chapter 11 just to kind of stay on track. We are slated for this unit exam. What did I tell you? The tentative. I bet I told you Wednesday, the 20th? Okay. Well, that's really optimistic. So it might be, we might bump it to the 22nd. Yeah, we kind of usually do that. That would be the latest it would be. So as of now, it's tentatively the 20th. So, yeah, if you know that you're going to be gone, and I'll know by Friday if we're going to have enough time to get through. But
You're killing me.
Welcome to college. So we need to finish talking about Midwest severe weather. And we talked about thunderstorms, and then we talked about, supercells, the squall lines. It's very exciting. Then we talked, I feel like Trump. We talked about lightning, and then, that's okay, I didn't vote for him. And then now we're talking about tornadoes, okay? So tornadoes then can drop from thunderstorms, okay? May or may not drop from thunderstorms. So thunderstorms are created or a great way to create them is warm, moist air. Of course, that's maritime tropical air intersects with cold, dry air, would be continental polar. Okay. So actually, and I like the way this reads, and I've mentioned this before, if you look at the United States, this is California, oh my goodness, that's awful. That's my worst yet. There's Florida. But the United States has actually mountain ranges on either side, which kind of makes a corridor, basically, where the warm, moist air can intersect with the cold, dry air. Okay? So, Tornado Alley. Now, I know Tornado Alley has been described to me in different ways. So, I just went out to the internet and said, what do you think Tornado Alley looks like? And I found this article that, to me, did a pretty good job. So the dark orange is old Tornado Alley. The lighter orange is the current new Tornado Alley. Where are conditions ripe to go ahead and give you these thunderstorms that may go ahead and have rotation to give you tornadoes? So we weren't in the old one, but we are in the new one. We weren't in the old one, but we are in the new one, that sort of thing.
I think it's weird that Florida, it's just like...
That's true. Tornado Alley, Florida? In the new, that's a good point. So,
why did they make the change?
I'd have to read the article. I'll go ahead and push it out there on Twitter feed. I think you look at my Twitter, so you can kind of read it in detail. But
they probably based it off of how many tornadoes occur in that specific area.
Yeah, I think the science. Remember, I was thinking this today. If you want to become a meteorologist, one of those fancy people that point. You need to be a scientist. And sometimes I've seen meteorologists, I'm like, you are not a scientist. But sometimes I've seen meteorologists, I'm like, dude, you are so a scientist. So I think the science is evolving, probably. It'd be my best guess. So this actually, I like to kind of look at this worldwide distribution of tornadoes, and you're like, where's the hot spot? North America. Now, this hot spot is different than, remember we looked at thunderstorms where they occur, and they were kind of like around the intertropical convergence zone and kind of a little bit all over. I just think that is so interesting. I think it kind of goes to our mountain ranges and the clashing of the two air masses. So this actually, I think your author was from Illinois because we see a lot of references to Illinois. These red lines are actually tornadoes. And they're kind of showing you one of the things we talked about. The general path that they go is generally from the southwest, from the southwest to the northeast. You kind of see that general idea. Some variance, okay, but more that way. You can make one of those rose wind things out of this, couldn't you? Yeah. Oh, actually, they did. Like up here. The percent, what's the longest one? Of course, that's the northeast. I was like, they should do it, and they did it. That's kind of an accumulation of this. They're so smart. So I've got a few tornadoes I want to kind of direct your attention to. The Parkersburg, Iowa tornado in '08. I've got a video and pics.
Where's Parkersburg at?
I think it's like north central. Or is it south? I don't know. Anybody know where Parkersburg is?
Google knows.
I don't want to take the time, quite frankly, to look at Google. I don't care that
I'll look
much.
now.
It's meteorology class.
So it's not coming up, so we might have to just skip it. So we'll come back to it. Maybe if it'll go on next one. Wake up, my slides are broken. Oh, there it goes.
It is. That's not funny. No.
There are actually different peaks depending upon where you live. As you might imagine, here in Texas, their season is a little bit earlier than ours. Okay, actually Texas picked that out, and it's actually got 2 peaks. Okay, so they've got a peak in May, and then they've got a later peak in September. So that kind of stinks. But when they form throughout the year. So the winds can be very crazy, very strange. So for instance, something that's very soft, like a piece of straw, can be poked through something that's very solid, like a piece of wood, just because of the energy and the force that it penetrates. Okay. For me, I didn't know what a gravity wagon was. You guys probably know. But for instance, this object has been picked up by a tornado and relocated 1 mile down the road. So we're talking about a little bit of force there. Okay. Yep. The mattress has been blown. A little bit of aerodynamics there with the mattress. A little bit of heft, though, too, depending upon the size of the mattress. Been relocated 40 miles. The record is a personal check that was carried along with tornadic winds, 223 miles.
Ooh.
Down that way.
Did they get it?
Brought it to a different state.
It's probably a cancel check, yeah. But, yeah.
That's crazy.
Uh-huh. It is crazy. So, again, tornadic winds. This is kind of some of the relocating of matter that tornadoes can do. So sometimes tornadoes, kind of like we talked about squall lines of thunderstorms. We talked about mesoscale convective complexes. Basically, we have thunderstorms, multiple thunderstorm cells working together. Well, sometimes tornadoes can actually come a bunch of tornadoes at once, and they call that a tornado outbreak. At least 6 tornadoes from one storm system. So these links actually, as you might imagine, take you out to the internet. I was curious, so what this one looked like in 1925. So there were, this outbreak. This outbreak doesn't say how many tornadoes there were, but there were 700 people killed. Now, one of the things, you actually have a homework question along these lines. 1925, do you think that their warning system was different than our warning system? Mm-hmm. Yeah, so 700 killed was in part due to that. So if you go down here, you can find anything on the internet, but you can kind of see. Is this the one called the tri-state, right? So you can see it go through 3 states. No, that wasn't the tri-state. This one, let's look at this one, 1999. Through Oklahoma, Kansas, Texas, and Tennessee. Yeah, these you might even remember some of these. So each one of these lines is, as I understand it, like another tornado. So
the green one was the main one then, maybe?
Not necessarily. The green one was just one of the outbreaks, one of the tornadoes associated with the overall outbreak. This one is that same one in 1999. Yeah, the colors are the storms, and like for instance, the red one had 14 tornadoes drop down from this, 20 tornadoes from Storm B, etc.
Wow.
Mm-hmm.
Got fast and intensified near more.
Mm-hmm. So categorizing tornadoes, you've probably seen a little bit of that already. And if you're familiar with the F, like an F5, that sort of thing, the F stands for Fujita, and I usually spell it wrong, but in fact, I had an instructor point out, he's like, you spelled that wrong on the slide, so I fixed it for this semester anyway. But the Fujita scale is the old scale. The enhanced Fujita scale is the new scale, okay? Both scales go from 0 to 5, and it's kind of like when we talk about hurricanes. Cat 5 hurricane's the worst, okay? An F5 tornado is the worst, or EF5 tornado is the worst. So in terms of, down here at the bottom, it kind of links the two, the old F scale and the new EF scale. Actually, as it turns out, the F scale was more intense than the new enhanced Fujita scale. But with regard to the old scale, the F scale, this kind of shows you your top powerful tornadoes, your F4s and your F5s. Only 2% of all tornadoes are F or EF, however you want to say it, 4s and 5s. Only 2%, but that accounts for 70% of all the fatalities. So the strong ones are what get you. The moderate ones, the F2s and the F3s, 29% of them are that. They account for 30% of fatalities. By far, almost 70% of tornadoes are your moderate tornadoes, your 0s to 1s, and we don't have many fatalities from those. So this kind of, I guess it's coming on the next slide. So what's the distinction between those different Fujita or enhanced Fujita tornadoes? This actually kind of shows you in columns. And one of the things that I think is significant or interesting is that these wind speeds, and I think I have it on a slide, these are estimated, EST, estimated afterwards. I got a sense from these couple of videos that we watched that it's really hard to chase a tornado. Maybe you watched kind of those on some other shows. It's like you don't know which thunderstorm cells are going to drop them. Even if it dropped a tornado, you don't know if it's going to drop another one, okay? And if you did know, thunderstorm cells don't always go in a straight line. So there's a lot of times they're steered actually by what's happening at upper elevations, you know? And so meteorologists can do their best to understand the path, but so anyway, it's categorized after the fact. Yeah. So this actually kind of summarizes what you saw a minute ago. Now these are F. This is the old scale, the F scale, not the EF scale. But the red line, okay, the red bar is how many there are. The orange bar is how many people die from them. So over here, we said the most violent ones. We have the fewest are that, okay, that's the red, but the most deaths occur are related to that. And I have a slide to talk about, safety things about tornadoes, which you probably already know. Watches and warnings. Watches and warnings are the same regardless of whatever severe weather you're talking about. So watches mean that conditions are favorable. And watches for tornadoes or for severe weather, not just tornadoes, are put out by, I think I mentioned this the other day, the folks in Norman, Oklahoma, which have had their fair share of getting creamed, okay, by weather events. I just think that's interesting. So they put out the they put out the watches. Now, the warnings are put out by the local folk. So warnings are put out by the local folk. And remember, we said that warnings for severe weather, you're not going to get one for lightning. You will get one for a certain amount of wind, a certain amount of hail, and if your weather or if your cell has been known to spawn tornadoes, they'll put out a warning. So that's the National Weather Service puts that out. So the Storm Prediction Center. So there are these things called convective outlooks. So hopefully we've talked a lot in here about convection, I feel like. Convection is basically warm air wanting to rise. We talked about that's one way. We said that if it gets warm down here, A little bit of hot spot that warm air wants to rise, that's convection. So convective outlook is looking at kind of the instability in the atmosphere. And that's put out by Norman, Oklahoma also, the Storm Prediction Center. So what they do is they kind of have a series of maps, and they go with probabilities. So you'll have outlook day 1, outlook day 2, outlook day 3, okay? So this is day 1, so this is 1 day coming up. Day 2 would be 2 days from now. Day 3 would be 3 days from now. And the high means a high likelihood, moderate, okay, less than high, and slight or marginal kind of goes down in possibility. So this is of any severe weather, and this one is just of tornadoes that are at least F2. Okay. This one is damaging winds, and this is the probability of hail. Okay, so these convective outlooks. And you know how people like to blog, you know? I don't know if that's a good example, but it's almost like it's not a blog, it's like a discussion board. The National Weather Service will have like a discussion board for the outlook where meteorologists kind of chime in with their thoughts about characteristics of what they know their location to behave and what they know about the science of the atmosphere, that sort of thing. So, convective outlooks. All right. So tornado safety, get indoors, right? Basement if you got it. If you don't have a basement, go to an interior room. Cover yourself with a mattress, which may or may not work for you. I think if you don't have a mattress, maybe at least a thick blanket or something, comforter, to protect you from flying debris. If you're in a mobile home, seek shelter in a different building or just outside in a ditch. Yep. If you're driving, get out of the car and seek shelter. I think one of the videos we watched not too long ago said never seek shelter under an overpass, okay? They're tempting, and I know that motorcyclists, get there because they are protecting themselves from rain, which makes sense. Motorcyclists. But the problem with overpasses is they kind of channel the wind. So basically the wind can be brought from this sort of volume to this sort of volume. It's called a gap wind. And it basically intensifies through So, and as strong as they appear that they are, they're not meant to withstand like tornadic winds or anything like that either. So, avoid those, even if other people are going there. It's kind of like one of those movies that you see, two camps like this, let's go over there. No, let's go over here. So don't go over the underpass. Get as low as possible. So I want to finish up by how do we see tornadoes? And I guess I would preface it with something I think I said before, that when you go, the National Weather Service, if you have a chance to go to a spotter training session ever in the spring, they will tell you what to look for, kind of like this is classes telling you what to look for severe weather. And one of the best tools they have is trained people calling them. But it's gotten even better. So like anymore, you can actually, you can email them. Okay, or you can, I think they have a website, you can actually fill in the blanks of what sort of weather you're observing as a spotter. So anyway, there's two types of radars. This is the normal, this is the normal radar. Doppler radar. If you're familiar with the Doppler effect, I'm going to kind of talk you through it. But Doppler radar shows precipitation, but it also shows rotation. Doppler radar will show rotation. The way Doppler radar shows rotation is it shows speed towards you and away from you. If I had something swirling here, can you see where part of it's going towards me and part of it's going away? Toward, away, toward, away. And actually, we can actually see that signature of a tornado in Doppler radar. Okay. So I'm going to kind of talk you through how that works. But anytime the meteorologist says, according to Doppler radar, rotation has been seen, blah, 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 that's exactly what he's saying. So as my next slide talk you through how that works. Doppler radar works using what's called the Doppler effect or Doppler shift. So anytime something's moving towards you, counterclockwise, yeah, that's okay. Round a low, it's going counterclockwise, that's right. Anything time something's coming towards you, let's see, ambulance coming towards. Yeah, so ambulance coming toward that person. Actually, the little red thing that the ambulance is sending out is going to be kind of squished together. So that person is going to hear it probably. The result is going to be audible. Pitch is going to be shortened. Okay, pitch is going to go up. Okay. In this case, the ambulance is going away, emitting a sound. In this case, the wavelength is drawn out, and what that has audibly is lowering the pitch. Okay, so it would be squished together and lengthened. And you may have heard this before. If you think of like a speeding car, when it comes closer to you, it goes. When it comes out towards you, the pitch is going up. It goes down, exactly like that. So that's the Doppler effect, and we can actually see things coming towards us, shortening, and away from us, lengthening, okay, using Doppler radar. So this down here just is another way to kind of show you the Doppler effect. The way this works is we basically have one object moving. Here it's at position 1, position 2, position 3. So actually it's moving towards location X. And as it moves towards location X, hopefully you can kind of see these squishing together. Okay, so actually the pitch would be getting higher for this one if it was a pitch thing. Over here, the same guy or the same source, we say, is moving away from this other location, so it's lengthening. So actually, hopefully you can kind of see these wavelengths lengthening. Okay, so I have kind of back-to-back radars. So normal radar is what we usually look at. Normal radar, if you see greens on a weather map, it's probably showing you normal radar. Greens mean rain, and then it kind of graduates to yellow, meaning more rain, and graduates to orange, meaning more rain, and to red, meaning the angriest amount of rain, lots of rain. You've probably seen these before. So the way regular radar works is it's called an echo, basically. It sends out a signal, and it waits for the signal to return because it hits precipitation. It's reflected back. Now, if it's not raining, basically that signal goes back, just goes on forever, and there's no echo. Okay? But if it's raining, it comes back. The amount that comes back is dictated by the heaviness of the precipitation. So that's how you kind of get these relative intensities of precipitation. That's regular radar.
Can clouds be picked up on radar?
Not this sort of radar.
Okay.
This is just specific for precipitation.
What about fog?
No. No. It's a different sort of imaging to get those. That's my understanding. The other type of radar is the Doppler radar. So actually these are of the same weather event. Okay, the one on the left is regular radar. The one on the right is that Doppler radar I was talking about. So what meteorologists look for in this Doppler radar is coming towards, away, towards, away, towards, away. And as it turns out, basically, they are looking for kind of a small area that looks like, let's see, what color would show up here? Can you kind of see the whole green, kind of the random green there? Okay. Like green represents toward, and red represents away. So toward, away, toward, away. That is showing rotation, but it's reflecting off of precipitation. Okay, so it's basically kind of showing this rotation within the shaft of precipitation. So we talked about tornadoes, and it's this big mesocyclone kind of in the middle of the cell that's making this tornado do its thing. So that is rotation. That thing right there, we call a tornado vortex signature, a TVS. That you get from Doppler radar. It's showing rotation. Okay. The other thing that meteorologists look for in regular radar is simply something called a hook echo. And these are terms that when things are getting exciting around the weather room at your local station, they will say, we've seen rotation, and we've seen that tornado vortex signature using Doppler radar. And then they'll say the regular radar, they won't say regular radar, but the regular radar is also showing an indication of a hook pattern. And regular radar is like an echo, so it's a hook echo. Okay, now to me, these are kind of hard to see. These are subtle things, but I've got some examples to show you. So this is the same storm system from left to right. from left again, you see regular radar, and on the right there, you see the Doppler radar. So the regular radar, you're kind of looking for this hook pattern. Again, it's kind of a subtle thing, but like outlined here, that's the hook. And if you do have a hook, your meteorologist will tell you that if you look in the hook, if you look kind of where I'll show you another example, it looks even better. Right there is where you should look for possible rotation. Okay, so the hook, that will bring you your hail. It's just kind of, and your tornado. So that is Doppler radar. TVS stands for Tornado Vortex Signature. Here's another example, left to right, regular radar, and this is Doppler radar. So I think you can see the hook better here. For this one, I can anyway. So kind of see the hook.
Is that white right there?
The red is the most intense rain, yellow less, green less. Okay, so that's the thing you're looking for, a hook in the precipitation.
That could be
in
like
echo.
debris too. Like that white.
The white a lot of times are just they're artifacts of, and a lot of times around cities you can't help but get some artifacts. So, but I'm not looking at the white. I'm looking at the red and the yellow. Can you see the red and the yellow and the green? That's the hook. So, and then actually corresponding, we see tornado vortex signature within the same region. So they kind of go together. So I kind of end up with some slides. This is actually a Doppler radar on wheels. So I swear I've seen these in Burlington area before. It's not that we don't generally know where we might get some severe weather that will spawn tornadoes, but we don't know exactly where they're going to be. So, okay, that's a Doppler radar on wheels. This is actually finally a pretty good example of, do you see the wall cloud? Those are kind of hard to, not all tornadoes are obviously give you that feature, but this would be the wall cloud. It's nice because it drops from the base of the cumulonimbus cloud. That is the regular stationary Doppler radar. Doppler radar on wheels, somebody hard at it. So National Weather Service, I know there's one in the Quad Cities and there's one in Peoria. And these little dots are where Doppler radar are. So I know we're bumping up against time, but I'm going to go ahead and hand out, and we're going to do a few slides on hurricanes. Just because.